So this is question 5 in a Mock A, and it's a difference equations question. It's particularly the first order kind. And it's about black rhinoceroses. So there are around 5,500 black rhinos left in continental Africa as I was researching this question. If left undisturbed, a rhinoceros pair can't produce any there. Rhinoceros, there's only a 90% chance that any given rhino will survive the next year. So that's the key word is that any given rhino. So that doesn't mean that the babies have a 90% chance to die and the adults have 50% chance. Is that in this model, every elephant has a 90% chance of surviving in the next year. At the same time frame, poachers kill 75 rhinos. Assume the deaths by poachers and other reasons are separate instances. So the death toll of 90% is actually excluding those who have died due to these illegal poachers. So show the population of rhinos in year n, that is Pn, is shown by the difference equation that. So if we have Pn in 1 year, the 90% are by the poachers, so we actually then have Pn plus 1. Well, we're going to have the original population down to 90%, and then those 75 extra ones are going to get poached. So this 0.9 Pn is we'll say natural deaths, although it doesn't imply that all the deaths are natural, but we're saying that those deaths are due to not by poachers, and this is the one by the poachers. So we'll just write down AQED. Write down the number of rhinos left after the first 4 years, subtracting from 55. So we have 5,500, so that's in year 0. Now we want 1, 2, 3, and 4. So, adding this on your calculator, use 0.9 times 5,500 and then minus 75. So the first one we get is 4,875, so it's a decrease. Then if you do 0.9 answer key minus 75, next one you get is 4,313. I'm rounding up here. 4,313. The next year it's going to be 3,806. And in the next year it's going to be 3,351. So it's 3,806. I can write that slightly better. So that's 3,806. I solve this difference equation with P0 equals 5,500. Now, there are multiple ways of solving first order difference equations. I'm going to show a couple of them during the videos. However, I'm going to use the method of just substituting and finding a pattern. So, firstly, well, if we let n equal 1, we get P1 is 0.9 P0 minus 75. Do P2, that's 0.9 P1 is 0.9 P0 minus 75 minus 75. Then P3 is 0.9 times this, which I'll write 0.9 squared P0 minus 0.9 by 75 minus 75 minus 75. So what we get is that Pn is 0.9 to the power of n P0 minus 75 times a geometric sequence where A is 1, R is 0.9. This is a geometric sequence. So, when we put P0 in with 5,500, we get that Pn is 5,500 times 0.9 to the power of n minus 75 by. Whoops. Oh god, what's going on there? 1 minus 0.9 to the power of n all over 0.1. So 75 divided by 0.1 is 750. So we get 5,500 0.9 to the n minus 750 plus those minuses 750 times 0.9 to the power of n. Now combining them together, I'll just sort of put over here, is that Pn is 6,250 0.9 to the power of n minus 750. And that is the solved difference equation. After how long will there be 55 rhinos left, which represents a 99% decline? So we just put this in as 55 is 6250, 0.9 to the n minus 750. Now that becomes 805. Divided by 6250 is 0.9 to the n, so I've just divided by the 6250. So n, if we log base 0.9 of 805 divided by 6250, we get it's about 19.4 years. So that's how long it will take for there to be a 99% decline. Now, are poachers allowed to kill any number of rhinos and keep the population of rhinos stable? Now, in order for this to occur, we have to think back to this equation here. So what we have there is because we have 75, what actually happened was that when we were solving our equation, we got 5500, 0.9 to the n, and then we got the number of ones that they got times 10, and so we can just add, or well, we can subtract the amount that they're poaching, which is x, which is 10x actually. It's 10 times the amount. And then plus, because the minuses were cancelling, we get 10x times 0.9 to the power of n. So once we combine that together, the general equation for x animals poached, we actually get 5500 plus 10x times 0.9 to the power of n minus 10x. So what we want is that the growth of actually this is to outpace this 10x. So how are we going to do that? Well, if we want this to be outpaced, we want this quantity to be bigger than this. So we want the 5500 plus 10x times 0.9 to the power of n. We want that to be greater than 10x for any sort of amount poached. So how we want to get what the value of x is, let's see. If we divide everything by 10, so let's divide everything by 10. 550 plus x times 0.9 to the power of n. We want that to be greater than x. So what I might do is actually expand it and try to get it in terms of n. So we get 550 plus x 0.9 to the n, then x. Now we can get x on its own, so we get 550 to be greater than or equal to x minus x 0.9 to the n. So we want 550 times 0.9 to the power of n to be greater than x times 1 minus 0.9 to the n. So, and actually having a look at this, we can get on x on its own. So x has to be less than or equal to 5500, or 550, 0.9 to the n, over 1 minus 0.9 to the n. So we can see that this is always written as 0, so we're not going to run into anything negative. However, this is very personal. I haven't actually thought of writing these questions. But what we can say is that this number is always decreasing. Because for larger and larger values, that's going to decrease. But as well, this is actually going to increase. So this decreases, and this increases. So if we try for different values of n, we can sort of derive a sequence and see if we can extrapolate anything from there. So we get 55 or 550 times zero point 0.9 is 495. Now dividing by this, we get that this has to be the amount killed within the first history, less than 4950. Show the sequence. So when actually trying to do it this way, you get somewhat of a false result. However, we when you're actually doing it this way, it can't work. But what's actually happening is that the population is never actually going to become stable if you think about it. So if it's decreasing every year, it's never going to become stable if you think about it like that. Because these give faux results, it suggests that okay, we can actually kill a certain amount, but it actually, relative to the amount that's actually alive at that point, it's somewhat of a silly statement in a way, because this number will keep rising and rising and rising because this number keeps it keeps increasing or allows the quantity to increase. So effectively, they're going to have to kill a negative amount of of of, of rhinos. So I know it's a very lazy way of doing it, but if you find a way to get this in a way that frames it in terms of X, please let me know. I can't. It's my first time doing it. I'm trying to do them all in one take because admittedly I'm very lazy. Right. Stay away with the potency to be deterred from killing rhinos. Pretty much anything works here. Like saying higher monitoring of rhino habitats. Pretty much anything there works. But I will have to think of a revision on this. But logically speaking, because it's decreasing every year, um, it's just a brief answer about the solve difference equation. Well, that's going to give faux results. And because the zero point 0.9 will always keep the population decreasing, there's no amount that poachers can kill in order to keep a decreasing population stable by removing more, if that makes any sense. So hopefully that was a good enough thing to warrant, yeah, hopefully it should be. And that's question 5 of mock exam A finished.